Hello.
Hello.
Hi, Enaho. Good afternoon.
Yeah, good afternoon.
Okay. Thank you so much for joining us. This is Oluwaseyi speaking. So I have all the learners on the Zoom link. I have Callistus here. He's in the front end track. I have Chikudalu, he's in the front end track. Elijah Ayodoko is in the software engineering track.
Cool.
Emma is in the front end track. Flint is in the UI, is in the software engineering track, sorry. Shino is also in the software engineering track. So I am going to leave you to it. Please introduce yourself, what you do, where you work, and then we can then go right into the session.
All right, cool. My name is Enaho Murphy, and I'm a software engineer. I work for a company called Unbird. Yeah. Just a little brief about Unbird. We kind of like working on the tool that helps companies aggregate feedback from multiple sources, categorize and analyze their feedback. So that's just all about Unbird. Right. I'm going to be sharing my screen as I walk you guys through a slide that I have. So let me just jump right in. Cool. Right. Can you get my screen?
Hi, Enaho.
Hello.
Okay, so we can't see your screen yet. Okay, yes, we can see your screen now.
All right, cool. Awesome. All right, yeah, so today I'm just gonna be walking you guys through, well, I was invited to talk to you guys about JavaScript, and the main topic is game development. As I go onto the slide, if you have any question, you guys could just indicate. If you can't hear me, just indicate, and I would like repeat what I said. Yeah, so like I said, my name is Enaho Murphy. I'm a software engineer at Unbird. Yeah, it's just like a little snippet I wrote there, which is I solve complexity by embracing simplicity. Readability is important, but efficiency is key. It's kind of like a reminder of how I work after all these years of like writing software. So I tend to like break complex tasks into simpler ones and then solve it bit by bit till I actually complete the entire puzzle. Yeah. So if you want to talk to me, I don't know. I'm most time always active on LinkedIn. I have a Twitter handle, but I hardly use it. So, but if you send me a message, I'd most likely respond to you. That's my GitHub account. If you want to check that out, there's nothing really fancy there. So, yeah. So those are the channels you can reach me if you ever feel like there's a need to talk to me. All right. So I'll be moving on to the next slide. JavaScript. All right, so just a quick, a quick note around this. JavaScript has gone through like a series of transition. But one of the best things that I feel like have happened to JavaScript over the last, I don't know, 4 or 5 years is actually kind of like a lot of push towards the standardization of the language itself. And you have that transition from JavaScript to ECMAScript where we have like a whole lot of standardization across browsers. If you were to write JavaScript like, I don't know, maybe 5, 6 years back, you find out that there's a whole lot of like issues with browser compatibility with the code you write, where you have to like write polyfills. Although there still are these days, but most software developers, they don't really get to face that issues because of tools like Webpack and Babel that just compiles the code down to um, older version of JavaScript. But it's very cool to see the future of JavaScript and how it's heading. And this whole standardization across browsers means that there's like more compatibility across browser than it was before. So that's like a really good thing. And the standardization across browser too as well introduced like some newer APIs like WebRPTC and Canvas APIs. Would actually touch a little bit on those on the later slide. Yeah, so browser meets JavaScript. Yeah, so it's kind of like a fun time to be a JavaScript. Like to be an engineer, it's a fun time to be an engineer. It's a fun time to write JavaScript because of the transition it has had over the last couple of years. And browsers too are becoming like very, very powerful. And with the advent of new APIs on browsers, the standards for building browsers are getting like stable, and newer APIs have been added. That means that very soon, most if you're going to build an app, you most likely want to build it on a web platform. We have things like Canvas, web notification, WebRTC, and the list goes on. But one thing you need to understand is that there's a core difference between browser APIs and JavaScript. Things like your DOM, for example, your events loop, Canvas, web notification, these are all like browser functionalities. And JavaScript on the client side just gives you setting like APIs to access these functionalities. So it's paramount for you to like understand the core differences between what's native to the browser and what is a JavaScript functionality. So yeah, so when you add like browser and JavaScript, you begin to see like the power that you start to have. And with the advent of WebAssembly, where you could actually write like languages like Golang on the client side, I feel like the future of software is going to be very neat. Yeah, so someone once said, I don't know who really said that. He said, if it can be written in JavaScript, it will be written in JavaScript. And come 2019, that's basically true. Everything is literally written in JavaScript. And anything that can be written in JavaScript, there's somebody out there that is writing it in JavaScript. You have game development, you have servers like Node.js, you have IoT devices all being powered by JavaScript. So it's a really fun time to be a JavaScript developer. Yeah, so today I'm just going to dive right in. I know you guys have been, going through maybe one language or the other. You've covered the basics of programming, so I don't really need to go through all that. You guys are already like programming ninjas. So I'm just going to dive right into like the whole game development bits in JavaScript. And sorry, I don't know if I'm going too fast. If I'm going too fast, can you just notify me? So I'll just take it slow. Yeah. So intro to JavaScript game development. Before HTML5 and the introduction of some of the neat HTML5 APIs that we have right now, Flash-based game used to be like the main deal. It's still the main deal right now, but the browser is getting so powerful, and the Canvas API is so powerful that these days you could literally build like very neat games on the browser with JavaScript. Even things like 3D and with the power of WebGL, you could do a lot of like very cool stuff on the browser with JavaScript. So the possibilities are just endless in the game development I'm seeing. Yeah. So for us, we are going to be working through like the game development scene, and the only thing the only HTML5 feature that I feel is quite relevant for us is the Canvas API. Like it's kind of like, so for you to literally like build a game, you need kind of a screen to draw on, a screen to write stuff onto, and JavaScript just provides that in a very in a very JavaScript gives us access to that because it's a browser feature via like some very nice API. And here, what you see on your left is just a snippet of such code to generate a line that cut across a canvas screen. We are going to explore like a little bit of example. I'm just going to flip back to my editor and walk you guys through some examples that I have. And yeah, so I'm going to run. So, right. Sorry about that. Locals, 1, 2, 3. Right. So I don't know. Can you guys see my screen? I'll keep on asking this question. Okay. Oh. Can you see my screen now? This is going to be a bummer if you can't see my screen. Zoom, let's. Kind of like, I don't know if you guys can still see my screen now. Right. I got a yes. I think maybe the latency. So yeah, so for me, this is kind of like a simple screen that I created using Canvas, and it just shows, you know, a gray screen with a ball drawn on it. I could come back here and walk you guys through how that is achieved, since I extracted all the canvas so new folder, screen, and just gonna come down here and copy this.
Hi, Enaho.
Yeah.
Okay, so have you started screen sharing? Like we can't see we can't see your code. We can only see your slide.
Here's my slide.
We can
Okay,
see
you
your
know what?
slide, but we can't see your code.
All right. Okay, thank you for telling me that. Let me stop this stream.
Okay.
Again.
Okay.
All right. Let me share again. Can you see my screen now?
So I think it's about to come up. I think we should just give it some minutes. You can see here that you started screen sharing, but we can't see your screen yet. I'm guessing it's the internet.
You know what? Just give me a second. Let me flip. Let me switch my internet and see if I get like another thing.
Okay, all right, thanks.
All right, guys, I'm back.
Okay, yes, you can see it. Yeah, you can see your screen now.
All right, cool. Yeah. So initially, I was showing just like the canvas.
Thank you.
I was kind of like showing the canvas API as just drawing like a screen and placing a circle on the screen. So that was like a code I wrote earlier. So I was just trying to just work with the same Canvas API without code. But yeah. So I'm going to refresh this, and this is just basically what Canvas API gives you. It gives you a screen and gives you a set of like tools to draw lines, circles, rectangles on it. Well, that's actually the fun part. That's boring. Just being able to draw circles is boring. Um, sorry, stop sharing my slide. Let me remove this. And all right, yeah. So, but the fun part about drawing stuff on the screen is being able to like move those stuff from one position to another position, which is where which is what brings us to the next part of our talk. So here we're going to dive into like more code, and I'll show you code samples that I've written and walk you through them. It's kind of like physics meets JavaScript. And don't let these make you think that I'm a physics genius. I'm not. I just barely know a little bit of physics and a little bit of maths. But the idea is that with a little bit of physics and a little bit of math, you could start like simulating real world actions on the canvas screen. So um, that will bring us down to vectors, velocity vector, and then um, foxes, because the vector is just like the coordinates, like an x and y coordinates on the screen, which is very important when working with the Canvas API. Being able to like draw stuff on a certain coordinates is a key thing in API, and trying to like decide the magnitude of that vector too is very important. And once we go through all that, when we now talk about like applying some sort of like force to that vector to cause it um, to move. Well, instead of me just talking about this, it's better I just jump into the code and just show you example snippet of what I'm saying. So the first walkthrough I'm going to have is what we call like a walker. I don't know if I call it a walker animation or whatever you want to call it, but it's just like single pixels on the screen, moving left, right, up and down based on control logic. So you're going to say, hey, I want you to take these points. I want you to move it 1 pixel to the left, 1 pixel to the right. And for every drawing cycle that we have, we are going to actually draw 1 pixel of maybe a dot on the screen. And for us to achieve that, I'm going to walk you through a simple example that I wrote earlier. Just first off, I'm just going to show you what we are going to achieve with this. Yeah, so you can see that, I don't know if you guys can see my screen clearly, but you could literally see some sort of like movement on the screen, kind of like a white movement. And that's kind of like just me drawing a single dot on the screen multiple times, repeatedly, which is going to be very important for game development. You want to be able to perform that action over and over and over and over again. It's very important for you to be able to do that. So for me, I'm saying that for every frame cycle, I want you to draw a pixel either to the left, to the right, to the top, or the bottom. And to achieve that, we're going to use an API, a browser API called request animation frame. So all this is saying is it's just like an endless loop. I feel like that's the easiest way for me to explain it. You have like an endless loop, but I call it like a gaming loop that repeatedly do stuff. So you say for every of those loop, we want to perform this action, maybe move a ball by 1 pixel or by 2 pixel or whatever on a X and Y coordinates. So for me, I created a worker class. I bet you all are all familiar with, classes. It's a new ES5 stuff that, it's dope to use. Yeah. So my class is going to take an X and Y coordinate. So the question is like, where on the canvas do you want to place that particular dot, like your first dot? And I said that, hey, I want to place it on the center of the screen. Yeah. So that's just it. And the canvas is just the screen itself, like the main canvas I'm going to be drawing on. So on that canvas, I'm going to draw a point on that X and Y axis. And then I'm going to say, hey, I want you to make that point white. That is it. That's the whole magic to draw a point. If I come down here and stop this step and reload my screen, you'll see a single dot on the screen, just a single dot on the screen. And the next part is that for every frame of the animation, I want to run this specific logic here, which is the main logic that takes it and move it 1 pixel and 2 pixel and whatever, and actually move it across like the XY coordinates. And for that, I'm going to be using math.random to generate like a random number and saying that if it's 0, then I actually want you to move that dot like to the right. And if it's, I don't know, if it's 1, I want you to move it to the left. If it's 2, I want to move it to the bottom. And if it's 3, I want to move it upward. Yeah. So basically that's like the simple logic that we are running here. And Down here, we are instantiating our worker class, and we are calling draw, which tells the frame how to draw the dot on the screen. And for every step, for every iteration, we just call step here, and that's where the magic happens. Like this is like a very minute example of what you can actually kind of like do with Canvas, right? Mind you, a simple technique you just want to understand is that your canvas is like an XY coordinate where the top here, if you can see my mouse, is like starts from, that's like the 0x and the 0y coordinates. I don't know how I don't know how mathematical everyone on this team is, but you would start to like grasp this concept once you start to play around with the Canvas API. So on this screen alone, I have this screen built out, and I set the width to default to 500 by 500, and that's like the width of the width and the height of the canvas. And so this part here will be 0, 0. While down here, since this is like on the y-axis, this would be 500, 0 on the x-axis, and down here would have 500, 500 on the y-axis, on the y and x-axis, and up here would have 0, 500. I know I'm going too fast because of like here, we have like a time constraint here, but that's like the basic idea of how you see your elements that you're drawing on the canvas on the screen. I have a couple of other examples that I could show you, but would actually touch that as we go through our slide. So you begin to see how we're actually controlling the vector and actually kind of like causing it to move one direction or the other direction. We could actually even scale our vector, and we would actually see some of the functions that we created to do that. But before I move on, I just want to let you know that before I move on, I just want to let you know that using Canvas is not as simple as this. Before this whole lecture, I went through the whole trouble of like abstracting all the Canvas like method of creating a circle, a line, and I don't know, all the stuff you're going to be using. So there's like a little bit of nuisance to drawing stuff here, but a good reference would be W3 School. They have like very good reference on how to do all this stuff, and I'll most likely be sharing a link to this code on my repo, so you guys can go check out how I'm actually creating these shapes. Yeah. So the next part that we're going to dive into is like the game loop. So I'm going to explain the game loop a little bit. Not that it's that complicated. I feel like it's the simplest part of the game that we're going to be building. It's just like it's just a loop. It's just an endless loop, and we're going to use request animation frame. If you really want to get to know like why request animation frame, I think we actually want to. There's a bunch of links I'm going to send to you guys once we're done. It's on Mozilla Doc. It gives you like a very good breakdown of why we use request animation frame. But this is just like a callback function that must be passed into it, and for every cycle, that callback function gets rendered, gets called over and over and over again till you stop the callback, which is the exact same thing we are using on our loop here. You're saying, I want you to draw a point here. I want you to step through for every of this function call. I want you to step through this, repeat this process. And then I'm going to call this request animation frame loop, both inside and outside the function. And that just does the magic. It just infinitely calls the function over and over and over and over again until you stop that particular call. And that helps us do a lot of stuff because, mind you, we are working with X and Y coordinates. I could say, I want you to draw a ball on this X and Y coordinates on the screen. And let's just go through it. Let's walk through it. I'm going to comment out the step function. And instead of drawing a point, I'm going to draw a cycle. I'm going to say, draw the cycle on the center of the screen, which is the canvas width divided by 2. To do division, you can still multiply by 0.5. And the canvas height divided by 2. And then I'm going to say, draw a cycle that is of 50 radius. I'm going to save this, and then I'm going to go back to the screen, and you're going to see the magic happen. Now, this is a cycle of 50 radius that has been drawn on the center of the screen. So the trick here with how everything plays in together, the request animation frame, the vector logic between like placing an object on a vector plane, comes where you start to like move that vector. So let's say I actually want to create like an endless loop, and for every of those loop, I want to move the x-axis of this particular ball to the right. So that is where it becomes like very interesting. So I'm just going to create a new method here, and I'm going to call it move. And I'm going to say for every draw cycle, I want you to take the x-axis of this ball, which is what is being passed here. Because this is an object, it's going to retain the last updated value of the x-axis. So I'm going to say add 1 to it, right? Which is cool. Let's say I want to move it like, one pixel to the right. And then for every of this cycle, I'm just going to call move instead of step. So you can see that just keeps like creating new balls on every, because we are drawing, mind you, we are actually drawing on the screen on every single cycle. So it's just going to draw another ball it's just going to draw another ball 1 pixel to the right, sorry. So a good rule of thumb we could do here is we could, on every draw cycle, we could set the background of the canvas before we draw. And here's what happens. Our ball is moving. But, well, it's moving off the screen, but the idea is that the ball is actually moving. That's the key part. So we are taking that ball and we are dragging it x, like plus x plus 1 to the x-axis of the screen. You can say 1 pixel, whatever works, to the screen, and you just see the ball move up. We could say, hey, we don't want to move it to the left, we want to move it down. And I would just comment this guy out, and we can say this does y, and we can say we just add 1 to it for every draw cycle, and that moves the ball down. We could say, oh no, we want to move it left. Instead of doing plus, we do minus x, and that moves the ball left. And we know the last one, which is y, and we know what's going to happen here. It's going to move the ball up. So when you grab the concept of the x to y axis, how you could actually update the internal state of an object on the screen, you can begin to move stuff across the screen. And that's the critical part in any game development I'm seeing, being able to actually move objects, have object interact, and understanding simulating physics on the computer would help you do just that. And that's like a whole different topic entirely that sits outside. It's a core part of game development, but it sits outside game development. And at the end of this thing, I'm going to share links that you could go learn simulating natural physics on your system. It's awesome. Once you start doing it, you just love it. Yeah. So that's the key idea between the game loop, the screen, and the objects moving. Now that we understand this basic concept, we could draw a ball, we could move that ball around. Yeah. So you begin to see, I'm just going to share you some cool examples that we have too as well. I think that's workout 2 index.html. So you see we have other examples here. You don't really have that much time to explain through this, but you can see that the ball is bouncing, it's hitting the edge, and it's bouncing back. So say, hey, if you reach the end of the screen, come back, don't go anywhere. If you hit the left, reverse back to the right, and you begin to see the cool stuff you could do with that. Yeah, so back to my slide. I don't know if I'm going too fast, but if I'm going too fast, please just let me know. I could always come back. If you have any questions to ask, also let me know. I could come back and talk about it again. Yeah, so that's that.
Thank you very much. And now, okay, thank you very much. And now, so we've told them to drop their questions in the Zoom group chat. So if they have any questions, they'll drop it in the Zoom chat.
All right,
Thank you.
cool. Awesome. Yeah. So, all right, this explains more about the request animation frame. So like, just a note, in each of the main method, these guys here, we schedule a new request animation frame before performing our loop content. So just think of request animation frame as just like an endless loop that for every frame, it actually kind of like withdraws your entire components. Initially, before request animation frame became like a thing on the browser, it was set time interval that was being used. But there's a whole lot of like nuisance as to why that is not the best way to go. On the link that I'm going to send to you guys, you're going to see, they're going to explain into detail why that is. We don't really have time to go into that as of yet. Yeah, collision detection. For me, this is like the most interesting part of, I don't know, physics or like, natural physics in computer or gaming. Is the idea of how do I detect when two objects collide. And that's interesting. For us, there's a whole lot of like, collision detection you could do. It's just like testing. I have a box and I have a rectangle. When do I know when both of them touches each other? That's the point. I actually want to know when a box and a triangle touches, when a triangle, a rectangle and a rectangle touches, when a line and a circle touches. I don't have to spell the thing out. I guess you understand what I mean. And the whole lot of like different collision detection. And I don't even know how to like, solve for almost all of them. So the beauty about it is I've been able to create like a lot of resource around most of this stuff. And I have like the perfect article to send to you guys to learn all the collision detection that you need to add to your code. For us in this, using this game, the only thing that we need to care about is like rectangle to circle. Yeah, that's literally the only collision detection that we need to get our game off the ground. But I'm going to show you a simple example. This particular example actually showcases collision detection on the screen. I want to detect when the ball touches the edge of the screen and send it back to the bottom. But I think I also have like a bunch of other collision example I can show you guys here. Cycled index if I haven't broken this yet. All right, I guess I have. All right, let's see. All right, so I can't really I can't show you guys a bunch of the collision detection examples I created because I'm quite certain I broke this stuff doing some sort of like refactoring before, like yesterday before this presentation. But as we go through like the game process, you're gonna see like a little bit of the collision detection in action. It's just a simple logic around how do we detect when a ball touches a pad. So because in our game that we're going to be building, we're going to have like a paddle where the ball touches it and goes back. And once you know when that ball touches the paddle, I want to send that back. When does the ball touch the brick and all those good stuff? That is where collision detection comes in. It's like an integral part of the game development cycle. And so the next part here is going to be like building a breakout game. So the whole idea of this game is, it might not be as fancy as this, but the idea is that we have a ball that is moving, across the plane of the canvas screen. It's just moving through XY axis, and it touches the paddle. It goes back, it hits a ball, and boom, the ball disappears. I'm not going to be like creating like a new project and writing this off, from the ground. I'm just going to be going through the code and walking you guys through every step of the way. If I feel like I need to rewrite something so you guys could get what I'm saying, then most likely I will just clean it up and rewrite it. But it's just going to be a walkthrough. Before I do that, I'm just going to show you end products. All right, got a message coming in. Okay. I'm just going to show you guys like the end product of what we have, which is self-serve. Hopefully I've not broken this. All right. So yeah. So this is an example. You can see that we have this cause updating up there, and once the ball goes past the bar, you will see that the lives, I'll let that be, you see that the life decreased. Maybe that experience is bad. That experience could be worked on, but this was a game I built last night, so I I wasn't really expecting anything fancy. And we can see that the collision detection on for the part to the screen is off as the part is going off there. I guess we might just fix that on this call. So this is the basic idea behind the game. You could, so that's just it. I'm just going to jump back into the code and just walk you guys through what we have. I'm going to close all this up and close this public. And I'm going to do a breakout. So first thing first that we want to do is we want to draw a ball, right? So I'm going to come down into this main file and I'm going to remove, I'm going to comment all these guys out. So I can give you guys a good walkthrough of everything we are doing. Right. So first thing first, we want to draw a ball. And that is where we have like a ball class. And this ball class just defines how the ball is being drawn. Okay, got a message coming in. Yeah, there are a whole lot of resources, and I'm going to compile all that and send to you guys just to, yeah, there are a whole lot of resources. Sure. So for me, I'm just going to walk you guys through. This is a whole lot of like stuff going on here, but the idea is that since we, if you can visualize what I said about the position being like an XY coordinate, so you think about that as a vector. So what you know, that just makes sense to abstract that into a class on its own, which is why I created a vector class. Yeah. So because I actually went on when I started this whole like stuff for this stuff, I went into the whole level of trying to build like a simple physics engine. And this vector class just stores X and Y coordinates, and that's all. Every other thing you're seeing here is just extra stuff that performs arithmetic logic on those coordinates. But the main thing that is important here is that it stores X, Y coordinates. So that is it. We're going to create a ball, and we're going to say we want that ball to be placed on the center of the screen and on the center of the x-axis, and then we want it to be placed on the center of the y-axis. And we want the width to be a 10 pixel. I check. Can you guys hear me? I don't know if I broke off or not. All right, cool. So I'm gonna continue and jump right in. Yeah. So like I said, a lot of things have been abstracted, which is like not the best way to teach, but we only have like a very limited time. But I'm just gonna do like a quick walkthrough around what we have here, since we have like a class called circle, and all the circle does is just it draws a cycle and that's it on the screen. And I've already showed you guys how to do that. And this is the only thing you need to care about. It uses the canvas to draw a cycle on an X and a Y position with a given radius. It fills it with the color being passed in and it gives you the stroke. And that's it. So once we take this ball, we've like demonstrated how to draw the ball. We're just going to go into the screen and reload. Our ball is still moving. I don't want our ball to move. I'm going to comment out this move function here, and then I'm going to reload the screen. So you can see our ball is placed on the bottom there. The next thing we need is we need a paddle, right? We need a paddle that would actually kind of like move left and center. So we have a paddle class, and all that does is the same thing, draws a paddle on the screen. Draw a paddle on the bottom of the screen. Once it grabs, I feel like the hardest thing, it depends on how inclined you are. If you are mathematically inclined, then most likely that mathematically inclined sounds bad. But if you kind of like a mathematical genius or whatever, I feel like you find the x and the y coordinates easier to grasp. If not, it's going to take a little bit of time to grasp like the x y coordinates. But once it makes sense, trust me, the entire game just makes sense. Because I want to believe that you guys are like very good at writing JavaScript. But once you understand how to place object on the X, Y axis, then you are set. That's all you need. The rest are just basic logic that you could just figure out. And for us, we're just drawing a paddle and we are placing that paddle on our game. So this is our draw function. You can see this draw function is what runs every time. And here we have like our loop. I've abstracted a loop too as well. I'm not going to show you what goes into there, but I'm going to share the code. You can take a look at it if you want. So our loop just calls this draw function over and over and over and over again. And for every of those like draw, we want to create a paddle. So I'm going to draw my paddle here. Mind you, all this here, you can see I create an instance of the board, of the ball, of the paddle, of the bricks. So I'm just going to draw my paddle here. So I'm going to come down here and reload this. Boom, my paddle is there. Simple. We have a ball, we have a paddle. Now let's make the ball move. I created a move function, and what that does is quite straightforward. So I'm going to go into the ball class. It's just my vector class, which does the X, Y coordinates, knows how to do things like addition, how to add two vectors together. So I'm just going to call like the position of my, how I move, how I scale the, how I scale my ball, moving from one position to another. I'm going to say that that's the velocity. And for every move cycle, I'm going to change that velocity. So it's quite simple. I'm just saying that, hey, the X and the Y, just add 4 to the X and the Y axis, and that's all. What that is supposed to do is it's just supposed to move the ball, 4 pixels in the X axis and 4 pixels in the Y axis. And when I call my move function, I'm commenting out all this detection stuff and reload this guy. Okay, sorry, I've not called move yet. I'm going to call move. You can see my ball is just going down. I'm going to reduce that a little bit and give it like 0.5, 0.1, and I want it to go up. So let's reload this. Nah, that's too slow. Let's make it 0.5. You can see my ball is going up. So the idea is that you can literally control the speed of your ball by just like adding to the velocity of the ball itself. And that is where this detection stuff comes in, which is pretty neat. Is that it's going to detect the edge. It's going to check if when the S coordinate of the ball has exceeded either the left, the right, the top, or the bottom, and it's just going to negate that velocity. So if I'm going to the X axis and I've passed like 500, if that's the width, I'm going to say, hey, I want you to go back. I want to set you to minus that and just go back. So that's kind of like how the whole detection stuff works. So I'm going to revert my velocity back to 4 and 4. And I'm going to leave my wall detection and I'm going to come back here. And you can see that my ball is bouncing back, which is like the example I created back then. So once you get this whole feel, the next phase would be like, okay, how do I know when the ball have touched the bat? And how do I know where the ball has touched like the floor of the screen? Which is where the collision detection stuff comes in. And I've already written that. I'm not going to like go ahead to explain all that because of time. I'm going to send you a link to where you could like get like a full, well-explained detail on how the collision detection stuff works. But it's quite simple. It's all mathematical. It's like jargons. But the idea is that I want to know when this circle is in a rectangle, which is the paddle. And I'm going to walk you through the game, and that's where I'm calling that. And mind you, all these are happening inside of the drop function. Like for every cycle, this is calculated and it just runs. The computer is so fast that you don't even see all these mathematical calculation happening. The games you play is the same thing. A giant loop running. There are some sort of like optimization that goes into the games you play, but underneath is like a giant loop running, redrawing every single graphics over and over and over and over again. And that's super powerful. So here we're just going to say when the ball is in, when the ball touches the paddle, we just want to, when the ball is in the paddle, let's just log something else here. This was called. And I'm going to open our console. And I'm going to refresh this up. And let's see what, I doubt you can wait for the ball to touch the paddle. You can see we got like a log statement out here. And that's super powerful. So now we can actually detect when the ball touches the paddle and when the ball does not touch the paddle. And because just with that simple logic, we could actually like create this old game over scenario if the ball is on the floor and it's not on the paddle. Yeah. So the next phase of this, which is like the key phase, is to draw the bricks themselves. And that too was abstracted into like a bricks class. But instead of me going through the class-based stuff, I went through the whole kind of like function constructor part. I don't know how familiar you guys are with older ways of writing JavaScript, but the idea is that classes are just syntactic triggers, and this is how your classes get compiled underneath. We have a function constructor, and we have like the prototypes where methods have been attached to that, and those methods are shared across class instantiation. So here it defines a single brick, which is a rectangle, simple, x, y coordinates, what is the width and the height. I already set up like base width and height here. And here is where we draw all the bricks. So we're using like a two-dimensional array where we save like the amount of bricks we want for every single render for every count, or for every row count we have, we generate that block. So this generates the block and this draws the block. And I'm just going to come back into the code and comment that out. So here we are drawing our bricks because we've created an instance of the bricks here and we are just drawing the brick here. So I'm going to reload this and boom, we have our brick. But one thing I'm going to do, but why this is just working straight off is because I did not really comment out the entire code. We already have collision detection attached to the bricks, but I'm going to show you the simple logic behind how that is achieved. So many ways that I could do this, but for me, I said I just put a little logic into the bricks. I said for every brick, I want to save an active state on that brick, and for every draw cycle, I'm going to check, because we already have the collision detection embedded into every instance of a rectangle. So it's easier for me to just call that. So because the brick already have like, it already knows how to detect the collision. So all I'm just going to do is I'm just going to say for that current brick, I'm going to check if the ball, which I passed into the function constructor, has touched like, is there a collision between the ball and the brick? If that's the case, then I actually want to set the brick states to false. So what this does is that if you understand that objects themselves are pointers, once you pass them into functions, you would know that even though I'm not calling this directly on the class, on the object itself, it's going to update the object. So the next withdraw cycle is going to say, is the brick active or not? If the brick is not active, then don't draw it. And boom, that is how that brick disappears. And you can see I have a lot of like other methods too, which is like update score, update counter, and stop ball. So these are all the logic that tells the ball, oh, if you hit this brick, what do you do next? If you hit the brick, do I go up? Do I come down? And so forth. And that is how like you get all this old logic just flying around. And once you have all that, the next part is now like, oh, how do my ball in the screen, I want my paddle to move. To do that, we're going to come down to the game. Then we're going to add like event listener. I abstracted this out, but it's a simple event listener on key down, on key up, where we have this paddle left and paddle right set to false. So once you press the key down, you want to set it to right. If it's the arrow right, you want to set it to true. If it's arrow left, you want to set it to true. And down in the drop function, we could just check if it's paddle left, move paddle left. If it's paddle right, move paddle right. And down in our paddle class, you can see how that paddle is being moved. It just checks, check a little bit of collision, does a little bit of collision detection check here, and it adds a vector of x minus 7, which is minus 7 to the x, and that would literally move the paddle to minus 7 is current position on the screen. And if you say move right, it's going to move the vector plus 7 to the current position of the screen. And mind you, this is moving on the x-axis because the vector holds like x and y coordinates. Mind, just a rule of thumb for understanding this stuff: x, y, x moves you to left and right, y moves you top and bottom. So if you say minus y, it takes you up. If you say plus y, it takes you down, and vice versa. Right. So down in the game, I'm just going to check for when any of this is true, and I'm going to reload this guy. And then you can see I'm using my keyboard now to move my paddle. The experience on this game is horrible because even when it touches the bottom of the screen, you don't see that happen. You just lose a life, and that's all. Maybe the experience could be better. But that's just the idea of like how to move the paddle. And you could even use your mouse to move the paddle too if you want for better experience. And for that, all I did was just within this, it's already abstracted how to get the mouse X and Y coordinates. But here we only need like to come down to, sorry. Yeah, so all we actually kind of like need to do is just update the mouse based on, you could abstract, you could literally get the mouse coordinates from adding an event listener to the window object. So it's as simple as that. Here, I'm just adding an event listener to the window object and saying if the mouse move, get me the client X and Y of the mouse. And then I'm just adding that to the actual position itself. And you can see now that I'm actually controlling the paddle with my mouse. Yeah. So the final phase of this game is how do we display the score and the lives? So that's still simple as well. What we did was we created a board, maybe leaderboard. Maybe I should have spelled that better. And then this just keeps track of the score, the lives, and high score. But there's no high score in this game right now because I did not build that in. And we are still using function constructor here instead of classes. This just updates the score, add one to it. So whenever there's a collision detection with the ball and the rectangle, you want to update the score of that of your board. And if the ball touches the bottom of the screen, you want to remove a live. That means you want to remove a live. And this is just a log function. We don't really care about that. Draw score just takes the score and draws it on these particular coordinates, these X and Y coordinates. And draw lives just take the total lives you currently have and draws it on these coordinates. So on the game, all I just need to do is call board.draw score, board.draw live. If I comment this out, you'd see that it's gone. If I come back here, you'll see that it's back. Yeah, so that's it for that. And finally, we want to know when to stop the game. And mind you, I already have an abstraction that removes, that stops the loop entirely. And all I did was the moment the live hits 0, I want to stop the game. Yeah, so let's test that out. Before that, I'm just going to show you one. Is N just checks when the ball touches the bottom of the screen. So that is it here. Is N just checks. Hello. I think I had like a tiny break in internet there. Can you guys still hear me? I check. Can you guys hear me?
I know, we can hear you.
Right. I'm sorry about that.
Yes, we can hear you.
Yeah. Sorry about that.
No problem.
Right. So when the ball touches the ground, you can see we are losing lives. Yeah. And the moment our lives gets to 0, boom, we stop the game. It's just what this part of the logic does. It just checks for the live, when the live, because we, in the board, you can see that we always like, we are subtracting the total live, which is set to 6, whenever you call update live score. And just to show you where that is happening, is within this same draw function where we detect if the ball has touched the rectangle. So when the ball touches the rectangle, then boom, we want to take that ball out of the screen and we want to update the score. We also want to like, update the live too as well. So when we have that, you just begin to see like our game just come to life. That's just the basic kind of idea behind the entire game. Because of time, I can't really go in deep and start explaining like every single stuff that I'm using, but it's the basic idea. You can draw stuff on screen. You know where that stuff is, the X and the Y axis on that stuff, and you can begin to move it left, you begin to move it right. And there's so many other cool physics stuff too that you could do even outside the old game, and the animations just get like very interesting. I'm going to share you guys like a lot of like articles and even videos, like free course tutorial that you could take on like natural simulation, and even some articles on game development. But the idea is that once you understand collision detection, you understand how to move objects on the X and the Y axis, the rest is just left to logic. It has nothing to do with the canvas now. It has nothing to do with the boxes. It has more to do with, how imaginative you are to solving a specific problem that or building a specific game that you want to go build. So that's kind of like, that's just the whole thing. This reset counter just resets the board whenever we have no ball again. So that's just it for the game. Too bad we don't really have enough time for me to like, go through it one after the other. But that's the basic idea for the game that, I built. No high score, sorry for that. So for me, I dropped a couple of recommendations. We've already gone past the scheduled time. The nature of code is on the top of that list because it's something that if you have like any interest in gaming, you should watch. And trust me, I only watched 2 episodes of, I only watched 2 sections of that video and it made a lot of sense. I've not even completed it yet. P5GS is a framework that allows you to do all this stuff I'm doing without the need of learning a lot of canvas and stuff. I had to because I had to go recreate all this stuff myself, and it's just for my own personal learning. You could always do that, but to get quickly started, you could always use P5 GS framework. Khan Academy has like a lot of, has a very good video on natural simulation. And then Mozilla Docs has like a lot of videos on video game anatomy. Yeah. So for me, to you guys, it's to build a single project. I'm going to share a link for you for all you need to learn, to go build this game. But it's just a simple tic-tac-toe game. You have X, Y, boxes on X, Y coordinates. The simple idea is you should be able to detect when your mouse touches the box, And once your mouse touches that box, you need to draw something there, right? If I'm going to show you like a very cool example before we round off this session. Hopefully, I've not broken that example yet. And all right, I think we did. Cool. So you can see this example. The example just like has ball flying around. But the beauty about it is whenever I click on the screen, it generates a new ball, right? So that's the whole Tic-Tac-Toe game to idea would still fall behind that, where you've marked out all the boxes on your screen, and you know when the user clicks on one part to draw an X or like a X or an O on that part. So it's going to be like super straightforward to kind of like do it. But the cool part is you should also like create like a simple logic that the computer too could create an O once you add like a S, and then you keep track of scores between computer and player, and then maybe persist the score in case the person reloads the browser. You get that score back maybe from local storage or whatever client-side storage you like using. And that's just a simple idea for the game. I was told that you guys would have to get back to me on the game. So for me, it's very simple. You create a PR. So you create a project on GitHub and just branch out from that project into like development or whatever. And then you raise a PR to the master once you're done. And I don't know how we're going to reach you, how you guys are going to reach me, but maybe whenever you get that link to me, I'm going to review the PR and yeah. So it's added bonus if you host the game on Heroku. That would be awesome. So I could actually play it myself. On the final, I just want to say like thank you guys for having me. And I have this little quote down here, not the most fanciest of quotes, but I like saying to myself that you don't know anything, but you do know everything. You need to know to learn anything. It's kind of like a cliche, but the idea is that for this particular presentation I'm showing you here, I built a Tic-Tac-Toe game on Java Android for like maybe 3 years back or so. And that was it. That was my whole introduction to gaming. When I was told to pick a topic to present to you guys, I was like, oh, JavaScript sounds fun. Why not do JavaScript and gaming? I had literally no idea. I did not really know how to simulate physics when I was sent that link. I literally had to learn all this stuff just to present it to you guys now. So that's the point I'm actually trying to drive here, is that you necessarily don't need to know everything. Every day I feel stupid. And even the more I learn, the more stupid I feel. But the idea is that you need to cover enough of the basics for you to go build anything. The moment you understand the basics, trust me, you could build on that and literally learn anything. And that's like my own state of mind, is that I have covered enough of the basics for me to go learn anything. Maybe it's machine learning, maybe it's IoT, maybe it's building games or whatnot. You just have to get to that point where you are comfortable to go learn anything. So that's just my own simple take on mostly learning on my own path. And thank you.
I know.
Hello.
I know.
Yeah, I can hear you.
Okay, so everyone is actually saying thank you here, but just so we're all together. I don't want to unmute everyone's mic, but they're actually saying thank you. Thank you very much. I think the last part, where you encourage them to keep learning,
Yeah.
I think that got them. They all smiled here. So they feel like they're actually not making a good progress. Like they want to know everything at once, but it's a good one that, yeah, I think what you just shared is very good. Thank you for encouraging them. So then you mentioned a couple of resources. They would like you to share that with them as well. I think we have them in the slide, but I'm not sure what the problem is. So Chikudalu, what's the problem with the resources?
Can you share, those resources, can you share them on Slack?
Like you want a link to the,
like
okay.
It's not recorded.
Okay. I know. Okay, so they want you to share links with them, links to the resources that you mentioned. And then for the Okay, so for the task as well, they would submit on Trello, and then we'll add you to the Trello board where you can review all their submissions, right? Okay, yes. Awesome. They actually have a lot of projects to work on, so we're adding this one to the project as well.
Well, yeah, it's a welcome to like it's welcome to the software award. Right? I told you guys that I had to go learn this stuff just to come present it here, and I also work too. I have like project, like real world project that I'm actually working on. I had to make out time to just go learn this stuff and just come present it to you guys here. So that's the one. That's the life of like we engineers. It's something that you guys are gonna come deal with in the real world once you get out there. So yeah, so keep fighting.
Thank you very much, Enaho.
Right,
it's been a very interesting session and so. Thank you. We're all saying thank you here. Thank you for making out time. Enjoy the rest of the evening. So I will chat you up on LinkedIn. Bye-bye.
All right, bye guys.
Bye.
It was interesting. I actually enjoyed it.
You enjoyed it?
Yeah.
Amazing.
It was actually fun. And I don't know what was explaining, at least the game was showing. So it wasn't.
The game was showing.
It was showing. Hey, you might chat our workplace.
So, how do I do this now?
Are you changing your voice? Yeah, I'm carrying your village. Look out. Now you sleep. Tomorrow, next week, finish my Friday. Yeah, there's internet videos.
There you go.